Hello everyone. We'll continue to learn about the next functional programming language, which is schema. Schema. The schema language, which is dialect of Lisp, developed in 1970s. So in the last video only we discussed about Lisp is the first programming language, and it have some dialects of the programming language of the same. So one of the dialect of Lisp is what? Schema. So this dialect word will give you the common features in language to language. In the same way, you will find differences in each. Right. Now, the first feature is what? It is a functional programming language. It also uses interpreter, and we were discussed about Lisp, where it is a typeless language, and schema is also a typeless language. We nowhere tell the data type of the tuples what we were using in the program. Those are what common features. Now here we go with the different features than Lisp or schema features that are. Schema is a static scoping language. We already come across in Unit 2 what is the scope, static scope, dynamic scope we come across. So if you have any confusions, you can watch that video. So schema is what kind of language? It is a static scoping programming language, and it treats functions as first class entities. What do you mean by this first class entities? First class entities in the sense, the first thing what I am writing there is function. Okay, let's see in the last example. I wrote here plus 5 comma 7 something, no commas, no comma we will use in between of this. Okay, plus 5 7. Now it treats functions as first class entities, means that this is what the first class entity, and it is treated as a function. As first class entities, schema functions can be the values of expressions, elements of list passed as parameters and returned from functions. Now, so while I am talking about the features, common features of Lisp and schema, we told about schema is a typeless language, correct? Same as Lisp, schema also typeless small language with simple syntax and semantics. And the very next feature is what? It uses interpreter as Lisp uses. So what do you mean by this? What it will do? A schema interpreter in interactive mode is an infinite read evaluate expressions where it interprets the expressions and displays the resulting value. The form of the interpreter, what we are using in this schema and Lisp, the same interpreters are being used in Ruby and Python also. The same functionality of the interpreter we'll see in both the languages. And the other different feature, what are different features? Static scoping languages different feature than the Lisp. The second different feature, schema supports primitive numeric functions, and somewhere I might have written that predicate. Okay, when time comes we'll see. So as of now it supports primitive numeric functions. Schema includes primitive functions for the basic arithmetic operations. These are plus, minus, star and slash. What do you mean by this? These are what primitive functions. Primitive functions. If plus is given no parameters, it returns 0. Why? Function with empty parameters, it returns 0. And plus adds all of its parameters together. That means plus is the function. Now what it returns? It returns 0. Plus 5, 6. What it returns? It returns 11. That means what? Plus adds all of the parameters together. And the next. If multiplication function is given with no parameter, it returns 1. Did you find the difference? If plus, both are functions. Plus is function, into is also function. Plus is a function with no parameter, gives 0. Multiplication is a function with no parameter, gives result as 1. Now let's see predicate numeric functions, expressions and values. This I wrote for our convenience. So into is what this multiplication is, what it's a function. The first class entity is treated as function in schema. The next two are treated as parameters. Now function will return a value which is 21. If I have given this one, this is what literal, number literal. So the same will be takes as the result. And if it is plus 578, then 20 will be the answer. How it will be? 5, 7 are parameters which are performed by this function plus. That means plus will add together these parameters. 5 plus 7 will become 12. Now this function is having again two parameters, 12 and 8, two parameters. Again this function is going to apply on these two parameters. In turn the result will be 20. Now minus is a function which is having two parameters, 5, 6. Now it will be what? Will be apply the function on these parameters I said. Now this is what the next entity and this is was the third entity. So that function will be performed on 5 minus 6. In turn the result is minus 1. The same minus function name is minus or subtraction. 15 minus 7. Okay, answer is what? 15 minus 7, 8. 8 minus 2, 6. So there are a large number of other numeric functions in schema which are modulo, round, max, minimum, log, sine and square root. We use uppercase letters for all reserved words and predefined functions. Now, so we will be defining the functions in schema. A schema program is a collection of function definitions. In schema, a nameless function actually includes the word lambda. Lambda is called as nameless functions. So now if I don't know what function it is, basically we know what it is. We'll be performing square of a number, right? That's what we will be understanding out of this square of a number. If I don't know the function name, I can take it as lambda. If I know the function name what I am going to perform, you can take it as a square root. Anything is okay. Nameless functions will be given as lambda. So the above is a or lambda is a nameless function that returns the square of its given numeric parameters. Now look at this. Lambda is what? It is function name. So as I wrote here lambda, it is a nameless function. User doesn't know what operation he is going to perform. In such case we use lambda. Now what is this x? X is a bound variable. X is a bound variable. During the evaluation of this expression, x is bound to 7. So this is what static scoping. We were discussed this point in the here, right? Somewhere I wrote static scoping language. That the value will be the value. This is what static value, and it is having static scope. So during the execution, this expression x is bound to be 7. And the next is numeric predicate functions. Okay, numeric predicate function. A predicate function is one that returns a Boolean value. So schema supports what type of functions? Primitive functions and numeric predicate functions. So predicate function means what? The name itself it tells that will be predict something. So the prediction is always will be true or false. That is what Boolean. So schema includes a collection of predicate functions for numerical data, and these are what that functions. Equal, not equal. Look at this function names are this. I told you already, schema will take first class entity which is function name. These are function names. Not equal, greater than, less than, greater than or equal to, less than or equal to. Is it an even number? Is it an odd number? Is it zero? For all the answer is what? True or false. Let's see, that we'll write something like this. 2, 3. This is what first class entity which tell us about function. 2, 3 are parameters. Now that means what? 2 equal to 3. 2 equal 3. Answer is what? If 2 is equal 3, answer is true. If 2 is not equal 3, answer is false. That's what the predicate functions means. Everything you can treat the same. Schema is also having one more advantage, one more feature, which are list functions. List functions, and these are, there are two sort of functions we'll be going to talk. The one is about CAR function. The other thing is about CDR function. CAR, CDR. Let's see about this. The reason to talk about this is, I told you clearly, schema is a language which is introduced in 1970. So at that time, we don't have the upgraded systems, upgraded processors what we are using now. That is what multiprocessor. At the time of 1970, we used to, the people used to use a IBM 704 computer. This IBM 704 computer uses registers to store the data. So now, concerned to this point, we are talking about two functions which will work the same, which are CAR, CDR. CAR is what? Contents of the address part of a register. Means what? We will return the contents of address part of the register. So let's see. This is what we discussed about list now. This is what list. List is having all atoms. So in all these atoms, first class entity will be treated as function name. BC are treated as parameters. Now CAR function applied on this list and asking to give the contents of the address part. So address part in the sense what? Function entity. Data part is in the sense what? In the sense what? Data part in the sense this parameters. Contents of the data part. Contents of the data part of a register. Contents of address part. Okay. So CAR, I told you function name will give you the address. Data means parameters will give you the address. If it is in the case of CAR ABC, means what? It returns address part. Address part means function name, which is A. CAR ABCD. Now AB is what? It is a list. You cannot divide this list into atoms. You cannot divide it. It is a list and the function name itself it is a AB. So we'll return AB. CAR A means what? It produces an error because A is not a list, and returns A because A is a list, and it is returns an error because no function name is specified. As if no function name is specified, you cannot tell address part of this function. And CDR is what? It returns data. I told CDR, the data is what? BC. A is what? Address. Or else A is what? Function name, BC are parameters. So this is the way how list functions will work in schema. So this is all about schema. Next video we'll be going to talk about the next programming language and what you understood about schema, as schema in which year it introduced, the common features in between Lisp and schema, different features of schema, and supported functions of schema, list functions of schema. So this is all about schema. Next video we'll be going to talk about the continuation part of functional programming languages. Thank you all.